So let's just focus on redefining a function. So let's try to redefine these functions which you have here, and then after redefining we should also try to sketch them. So let's start with the first question. So redefining a function is something which is very simple and straightforward as long as you follow the simple principle and steps which I'm going to give you right now. So let's start with the basic, or let's start with the parent function. If you have got f of x as the modulus of x, how do you define this? We know that if we have got x in the modulus is plus or minus, and definitely when we're talking about plus, okay, plus is the same as greater than or equal to. Okay, we are saying if it's greater than or equal to, it's maybe we can say starting from 0 all the way to positive infinity. But if it's negative, meaning it's just less than, not less than or equal to, no, but just less than. Now if you are trying to define the modulus of x, okay, meaning that you multiply it by a positive. The one you are going to multiply it by a positive for x has to be greater than or equal to 0. Then you multiply it again by negative. The one you are multiplying by negative for x has to be less than 0. Meaning that the overall now when I'm redefining this is going to be x, the condition that x should be greater than 0, greater than or equal to 0. Then negative x, the condition that x should be less than 0. Meaning that I've redefined this to be what? To be that. That's all. Okay? But now, in a case where we have this type of question, so let's start with the first one. So we are trying to redefine. Now we can't redefine these two because we have got plus in between. So we can't redefine using, we can't combine them. We need to redefine x minus 6 on its own, x plus 1 on its own. So what I mean is, so I'm going to start x minus 6 in the modulus. I'm trying to redefine. So I'll put this. Now I know that what is in the modulus here, just get the way it is. First you multiply it by positive. So if I multiply that by positive, I'll just end up having x minus 6. Then the condition is that the same one which is in the modulus, x minus 6, should be greater than or equal to 0 because I've multiplied this by positive. When I multiply it by negative, I put them in brackets, then the condition that x minus 6 should be less than 0. Okay? Now, when I do this, I need to find the value of x here. And I know that what I have there is x minus 6, same as equal to, I can say it's the same as equal to 0. Okay? Or, to make things simple, greater than or equal to 0. So if I shift 6 to the other side, x will be greater than or equal to 6. Meaning that the next step here is going to be, if I multiply positive by everything inside, it's going to be x minus 6, the condition that x is greater than or equal to 6. The second one, if I multiply by negative, it's going to be negative times x is negative x. Negative times positive x, or positive 6 is positive 6. The condition should be x is now less than 6. I've redefined this to be equal to that. Okay, so let me just put it here. I've redefined 1 minus 6 to be equal to, okay, that is x, not 1, sorry. So x minus 6 to be equal to, I've redefined it to be equal to x minus 6, comma, x is greater than or equal to 6. Then negative x plus 6, the condition that x should be less than 6. I've redefined it. Now let's also go ahead and redefine the second one, which is x plus 1. So I'll say x plus 1, redefining that, we follow the same principle. So first I need to multiply by positive. X plus 1, the condition that x plus 1, if I multiply by positive, is greater than or equal to 0. Then I multiply by negative, x plus 1. The condition should be the same one but less than 0. Then we solve for x. So if I solve for x, here you clearly see that we have x, okay, we have x minus plus 1 greater than or equal to 0. If I solve for x, x will be greater than or equal to neg 1, meaning that even the down part is going to be x is less than neg 1. So if I continue this from here, we can clearly see that we are going to have, if I multiply positive here by everything, nothing is going to be affected inside, so I'll have x plus 1. The condition that x is now greater than or equal to neg 1. Then here, if I multiply by negative, it will be negative x minus 1. The condition that x is less than neg 1. I've redefined now this one as well. So now, allow me to put this one just here. Okay, I will just put it here to make things simple. So I've redefined x plus 1 to be equal to x plus 1, the condition that x is greater than or equal to neg 1, neg x minus 1, the condition that x is less than neg 1. I've redefined it now. After doing that, since there is plus, we are adding these two things. The only thing which I can do is I need to use a table. So I'm going to use my table. So here is my table which I'm going to use. Now this table, I want you guys to understand what's happening here. So initially what is happening here is we have two values. Okay, we have two values which we have found. We are dealing with neg 1 and 1. Okay, so we are dealing with neg 1 and 1. So what we're going to do now is I'm going to put these values on the table. So we know that neg 1 is let me just get rid of these two lines here down. Okay, we have neg 1 and 6, so I'll put neg 1 here, then 6 there. Now one thing we need to understand here is this: we are dealing with the greater than and the less than. So the numbers which are coming from negative 1 going all the way this side is less than negative 1, meaning we are following this condition here. So here I'm going to say x is less than what? Negative 1, meaning I'm done with this part here. Let me just put here x should be less than neg 1. This neg 1. So for this one, we have used it. Next, here we have got x, 6. Numbers from 6 going this side is greater than 6, meaning that we are dealing with x is greater than or equal to 6. So I'll say, if I want, I can just say x is greater than or equal to 6, or it's the same as I just put it like this. What I mean 6 is less than or equal to x, it's the same as x is greater than or equal to 6. It's the same thing. Okay, so when I do this, in between here now, this one I've used it, I'm remaining with this guy and that guy. Okay, so we know that in between here, for the one for one we are remaining with is x is greater than or equal to, meaning that I need to say greater than or equal to x. Negative 1 is less than or equal to x, which is the same as negative 1 less than or equal to x, same as x greater than or equal to neg 1. Okay, so you are not supposed to be confused here. So we have used now what? We have used this guy. We are remaining with 1. The next thing, we go to 6. So 6 is less than, then I need just to say x is less than 6, meaning I've also used this guy. Now when I do this, I need now to use the guys which I know what in modulars. Okay, so I'll start with the first one, which is x minus 6. So x minus 6, we are dealing with this part here. So we are saying that the first box is x is less than negative 1. In the first box, if I go here, which one is telling me that x should be less than -1? I can clearly see that the one which is talking about the less than is the second one, meaning I'm going to put x minus or plus 6. I'm done. I go to the next one. The next one we are dealing with is telling us that -1, x is greater than -1 but should be less than 6. Okay, meaning we are still dealing with the same one, because this is saying that x should be less than 6. But again, if x is less than 6, it can be greater than -1 but less than 6, so I'll still get that. Finally, x is greater than or equal to 6. We know that we are going to get the first one. I'm done for the first part. Then I move to the second one, which is x minus plus 1. So for the first part, which one is telling us we are now here? Which one from this line here, which one is telling us that x is less than -1? It is the second one, which is -x minus 1. We jump, we go to here. Which one is telling us that x is greater than -1 but less than 6? But initially we don't have less than 6, so we're talking about greater than 1, which is the first one, x plus 1. Then which one is also telling us that x is greater than 6? Is again the first one, x plus 1. When you do this, meaning there is plus here, we are following this sign here in between. If there is minus, we're going to do minus. If there is plus, you're going to do plus. So now there is minus. So what we're going to do is we need to add. Let me just push this one a bit on top there. And then I get rid of this. So we need to add this plus that, this plus this, that plus that. Then the conditions, that's why it's very important for you to focus on these. These conditions are very, very, very important. So I'll say x, I'll put it here, x minus 6 in the modulus plus x plus 1 in the modulus should be equal to, I'll start with the first part. We are saying -x plus 6, again plus, we're following this sign here, then plus what we have here down, again -x minus 1. What is the condition? The condition for this box is that x should be less than -1. X is less than -1. Done. In between we have got x plus 6 plus x plus 1. The condition is that -1 less than or equal to x and x less than 6. Done. We move. So we have the last one, which is this. We add those two. We have x minus 6 plus x plus 1. The condition is that x is greater than or equal to 6. Then we add. So if I add x and this one, is going to give me -2x. 6 minus that one is going to give me plus 5. Perfect. What is the condition? The condition that x should be less than -1. We go to the next one. X and x will cancel. 6 plus that one is 7. What's the condition? The condition is that -1 less than or equal to x less than 6. The next one, x plus x is 2x. -6 plus that one should be -5. What is the condition? The condition that x should be greater than or equal to 6. So if the question is just asking you to redefine this function, this is the answer, the final answer. So we have redefined this function. Now after redefining this function, you need now, in a case where you are going to be given, let me give an example. For example, let's say we have f of x is equal to x minus 6. They just ask you redefine. That's the answer. It ends there. They just ask you this part only to define. That's the answer. Like the way it is, the combination of this and that one, the answer is this one. Okay, so we have been told to redefine and sketch. So we have redefined. Now let's try to sketch. Sketching this is something which is very simple. As long as you know how to sketch piecewise function, I believe this is going to be simple for you. So let's try to sketch now. So I'll need first to come up with the to my simple coordinate. I'll start with the first one. You know, this is sketching. This type of graph is very simple because you have the domain already. So we are saying that x should be less than -1, meaning -1 going all the way to -infinity. I'm going just to get two coordinate, -1 and what? I'll get -1 and -2. So let's see. If we put -1 where there's x here, it's going to be -1 times -2 is +2. +2 plus 5 is 7. But remember, it is less than. At this point, it's going to be open. If I put 2 times -2 times -2, 4. 4 plus that is 9. I'm done. Next coordinate is going to be in between. In between here, we have been told that it's just -6 all the way. I can just put -1 here and then 6. We know that it's going to be, when we put -1, we have just 7. We have just 7. We don't have any value of x. If we put 6, it's 7 again. We are done. But at this point, it has to be included, but at that point, it has to be open. The last one is the third one here. So we start with 6. If I put 6, it's going to be 2 times 6 is 12. 12 minus 5 should be 7. Okay, is greater than or equal to, it will be included at that point. Another point, I'll just get 7. 7 times is 14, so I'll get a 9. Then now I can sketch. I can now sketch. So in x, we expect to have -1, -2. In y, do we have positive? Yes, we have 6. And then in y and also 7. Let's just say 6 here, 7. So in y, the values which you have, I've got 7 and 9. That's all. So I'll just put here 7, 9. So the first coordinate is negative. In fact, let me start with the one in between here, which is -1, 7. -1, 7 is here included. Then 6, 7. 6, 7 is here not included. So I put a line there. Then I'm done with this. I can go to that one. -1, 7 open. It is open at that point. Next we have what? We have -2, 9, which is here. So I can clearly see that my graph is going there. You put an arrow, we don't know where the graph is ending. Here we have 6, 7 included, so I'll put it inside there. Included. 9, 7 again is here. We don't know where the graph is going, is ending, so I need to put an arrow as well. So I have redefined as this one. I have also sketched. So you say that's the graph of f of x is equal to the modulus of x minus 6 plus the modulus of x plus 1. Like that, as simple as that. What I've done here, you do the same thing to solve part C. It's definitely the same thing. Okay, so I'm going to do part B. Again, if I do part B, that will be the same thing you can do also. You follow the same principle. I want you to go ahead and solve part C and D, then you send me the solutions. Okay, if you have the chance to send me the solutions, you'll be able to send me the solutions, or you can just leave the answers in the comment section. I'll be able to see them. So let's go to part B. So part B, we are trying to redefine as well. Let's go ahead and see. So we redefine the first one. So to redefine this, we know that for the first part we multiply by positive 2x minus 1. The condition is that 2x minus 1 should be greater than or equal to 0. Next, I multiply by negative 2x minus 1. The condition that 2x minus 1 less than 0. Let's go ahead and finish it from there. So this one, the positive will not affect anything. Now let's solve for x. So we solve for x, we'll have 2x minus 1 greater than or equal to 0. 2x is greater than or equal to 1 divided by 2, 2x is greater than or equal to half. So the condition now is that x is greater than or equal to half. So for the second part, it's going to be negative, or negative times 2 is going to be negative 2, then it will be plus. Again, we'll still have the same condition. So I've redefined the first part, of which I'm going to put it here. I'll put it there. So we have 2x minus 1 for x is greater than or equal to half. Then negative 2x plus 1 for x is less than half. Done. I've redefined the first part. Now let's go ahead and redefine the second part. So the second part is x plus 2. We know that for positive x plus 2, the condition that x plus 2 should be greater than or equal to 0. If we multiply by negative, the condition will be that x plus 2 is going to be less than 0. Let's solve for x. So x plus 2 greater than or equal to 0. Shift 2 to the other side, x will be greater than or equal to negative 2. So we finish it from here. We can clearly see that positive will not affect anything. So if I multiply by positive, it will be x plus 2. The condition that x should be greater than or equal to negative 2. Then the next one will be negative 2, negative x, minus 2. The condition should be x is less than negative 2. I've redefined that one, of which I'm going to put it here. Okay, let me just put this part there, then this part here. Okay, now we can also, now there is minus there, so we still use the table to find the values. Let's see. So I'll have the table here. Okay, can you put it there? Another one here, another one there. Or let me put this table here so that I have space this side. I'm going to use it. Okay. Okay. So I have 2, so I need to do this. That's all. So what values are we dealing with? We're dealing with 1 over 2 and negative 2. So I'll put negative 2 here and 1 over 2 here. Now, the numbers from negative 2 going this side, they are less than negative 2. So meaning that x is less than negative 2. We are done with the first part here. So we have used this. Then the numbers from here going to this side is greater than. Which one do we have greater than? Is this guy, the first part, but is what? So I'll put this. Like I said, 1 over 2 less than or equal to x is the same as x is greater than or equal to half. It's the same thing. You can clearly see that the open side is where the x is. So it's the same thing. So I've not changed anything there. In between here, so I've used this, I've used that. We are remaining with 2. In between now, talking about 2 is greater than x. So I'll say less than or equal to x, but again less than half. So this one less than negative 2 is less than or equal to x. It's the same as x is greater than or equal to negative 2. Then x is less than half. It's just direct here. So I've used everything now. So when I do that now, I need to start now putting this. I'll start with 2x minus 1 in the modulus. Okay. So if I put for the first part here, which one is telling us that x is less than negative 2? The one which is telling us that x is less than negative 2 is the second one. Because the second one is saying that x is less than half, meaning that I'm going to get negative 2x plus 1. Again, for the second, for the same one, which one is telling us that, since we are dealing with half, which one is telling us that x is less than half? So it's the same one, negative 2x plus 1. Then for the last one, which one is telling us that x is greater than or equal to half? It's the first one here. So I'll get 2x minus 1. I'm done. I go to the second one, the modulus of x plus 2. Which one is telling me that x is less than negative 2 for the second one? It's this one. So I'll put negative x minus 2. Then here we are dealing with 2, so I'll concentrate on 2. Which one is telling us that x is greater than or equal to negative 2? It's the second one. So I'll put x plus 2. The second one is, which one is telling me that x is greater than half? It's the same, the same second one. I'll use it there. When I do that now, since there is minus, I need to add these things. I need to subtract, not adding, because there is minus. So I'm going to say this minus that. So I'll say negative 2x plus 1. I put them in the brackets, minus negative x by minus 2, like that. So what is the condition? The condition is that x is less than negative 2. Okay. On the middle here, in the middle here, we have negative 2x in the brackets plus 1 minus in the brackets x plus 2. I'm just getting this and that. Now what is the condition? The condition that negative 2 is less than or equal to x and x is less than half. Done. Let's go to the last one. In the brackets x plus or x minus 2 minus 1, sorry, then we have got also x plus 2. What is the condition? X should be greater than or equal to half. Done. Now I need to add now, finding the final answer. So it's going to be now, it's like I have, let me just rewrite this. I want to open the bracket now. I have got negative 2, I want that negative to be visible, negative 2x plus 1. So this negative and this is going to be plus x plus 2. The condition that x is less than negative 2. This negative and that will be positive. Even there it will be positive. That's what we should know. Then here I also open the brackets. So it will be negative x minus 2. The condition that negative 2 less than or equal to x less than half. Next, I'll also open the brackets. So here it will be minus this minus 2. This and that negative, this and that negative. The condition that x is greater than or equal to half. Okay, let's finish it from the top part here. So our final answer when we redefine will be this, and this will give me negative x. This and this will give me plus 3. Okay, the condition x less than or equal to, or is just less than negative 2. So here we can clearly say that negative 2x and this is going to give me negative 3x. Then this and that will give me negative 1. Okay, the condition is that negative 2 less than or equal to, okay, negative 2 less than or equal to x, and then less than half. Then for this one is going to be this guy, and that one will give me positive x. Okay, positive x, then negative 1 and that one will give me negative 3. Let me write it properly. Will give me negative 3. So the condition is that x should be greater than or equal to half. Okay. So here initially I want just us to be sure on the one in on the middle here. So we are saying this and that. If we do minus, okay, yeah, it's giving us the correct thing. So let's see what we're going to have. Let's create space. We create space, we see what we're going to have. So we are trying now to sketch. We are trying to sketch. So we create space on top there so that we see how we can sketch this. Okay, so let's see. So now when the issue of redefining this one alone, I have redefined, this is the final answer for redefining. That's the final answer for redefining, but we are trying to sketch it. So let me get rid of everything here. So sketching, let's first come up with the coordinate. Like I said, I'm going to come up with coordinate this side for the first part here. So if x is negative 2, but at that point it's going to be included. Even if you don't show that it's included, it's okay. You just put the lines. It's alright. If I put negative 2 here, it's going to be positive. Okay? It's going to be positive 2. Positive 2 plus 3 is 5. Okay? If I put negative is less than negative 1, let's put negative 1. If I put negative 1, it's going to be what? If I put negative 1 times this one is going to be positive 1. So it's going to give me 4. If I put 0, it's going to give me 3. I end there. In between, we have been told that the values of x should be in between negative 2, -1, 0, and half. Just like that. So if x is negative 2, let's see. If x is negative 2, negative 2 times this one is positive 6. Positive 6 minus this is 5. But at that point is included. Okay? Then negative 1, if it's negative 1, but initially the best thing what we can do without us, I don't want us to waste time. I can just go direct to half, because I need just to connect the line which is going to be negative 2,5 and the 1 over 2. So if I put 1 over 2, times neg 3 is going to be neg 3 over 2 minus 1, of which is the same as I put 2 over 2, so negative 5 over 2. So it's going to be negative 5 over 2, like that. In between here, if you want, just ignore, because you are going just to connect the line. Then the next one will be, if I put half, what do we expect? We have x minus 3. So half minus 3. Half minus 3 is the same as, we say 1 over 2 minus 6 over 2, like that. Because 6 over 2 is negative 3, like that. So meaning this is going to be negative 5 over 2 as well. Negative 5 over 2 again. Then I need to have another coordinate. Let's just get 1. If I put 1 minus this is going to be negative 2. I end there. If I want, I can put 3. 2. 2 minus that, neg 1. Not so. Yeah, neg 1. So we have, so from here now I can sketch according to what I have here. I can now have my graph. How do we expect our graph to be? Here. So we have the x values. Allow me to put this one just to be there. Okay. The x values, we've got negative 1, negative 2. Okay. So the negative part, we have neg 1, neg 2. The positive part, we have got 1 over 2, 1, 2. 1 over 2, 1, 2. Then the y, we have got 3, 4, 5. Then the negative side, we have got only negative 5 over 2. That's all. Oh no, we have negative 5 over 2. Let's not forget this. We have neg 1, neg 2, and negative 5 over 2. Okay. Then the positive part, we have 5. We have 3, 4, 5. 3, 4, 5. 3, 4, 5. So if we are to sketch, let's start with the one in between, because that one requires us to put a line. Negative 2, 5. Negative 2, 5 is here. Where is it? Negative 2, 5 is there. Then negative 5, 2. Negative 5 is here, 2. 2 is there. Okay, so before I put the line, I want us first to do 1 over 2, 1 over 2, 5. Again, it's the same point. 1 over 2, no, it's here. 1 over 2, 5. 1 over 2. So we are starting with the first part. No, this one we are saying is 1 over 2, 1. This one is negative 2, 5. That point is correct. Then negative half, negative 5 over 2 is here. Half, negative 5 over 2. It should be here. Yes. That's now perfect. Not this point. Okay. Not that point, no. Another one, we have, so can I have a line there before I even connect the line? Let me first do negative 2, 5. Negative 2, 5 again is that one. Then we are saying negative 1, 4. Negative 1 is here, 4 is there. Okay, that will be better, I think. Next we have 0, 3. 0, 3 is somewhere here. In x 0, in y there. Okay. It's now making sense. Okay, so and then what else do we have? What else do we have? So we have 1 over 2. Where is 1 over 2? 1 over 2 comma 5 negative 5 over 2. 1 over 2 is here, comma negative 5, which is here. Okay, then 1 in x1 in y negative 1. Okay, that is that point. In y negative 2. So x1 in y negative 2 is this point. Let me get rid of this. Is that point? Okay, another point is 2 comma negative 1. So 2 comma negative 1, which is there. So now this graph, the way it's going to be, is like this. Let me show you. From this point here, it's going direct, just straight there. You put an arrow, we don't know where it's ending. Then from here, it comes like this. It comes here. When it reaches there, it has to turn. Okay, when it reaches there, we have this point is supposed to be somewhere here. 4 negative 1 is here. Then it has to come like this. Then it comes from here. Now the line has to come like this. What I mean here is this. There is a point in between here, I might forget, but this is how the graph is supposed to come like. So here you put an arrow, we don't know where it's ending. So now this graph, the way it is, initially only that it's looking more as if the shape is not making sense, but initially it was supposed to be like it comes there, it comes there a bit, then it goes like that. But it's the same thing anyway. It's just sketching. No one is going to penalize you. So if you do your math correctly here, we are supposed to get a perfect graph. Okay, for example, here if we are to put, where is it? Yeah, the one in between here. If I'm to follow this one correctly, if I put negative 1 here, it's going to be negative 1, which is going to be positive. So which is going to be 2 minus 1. What is 2 minus 1? It's 1. So it was supposed to be to go at 1 comma 1. Okay, which we have it already. So if when I have got 0, it's going to be at negative 1, negative 1. So at 0, then negative 1 again here. That's why I said it was supposed to touch this line, this point here. Or let me just do this before we go there. I want to redo the points. Just a minute. We'll do the points. So what I mean, guys, is this. We started with, let me start from here. We started with this. I said that here is we have got negative 2. Let's just get 2 points. Negative 2 and negative what? Negative 3. Because these are numbers which are less than negative 2. If I put negative 2 here, it will be 2, 5. If I put negative 3 here, it's going to be 6. Okay? And then if I put, yes, it's going to be 6. So that's where I made a mistake, where I was saying it was negative 3 comma 0. No. So now the other one in between here, if I put the numbers negative 2, neg 1, 0, half. If I put negative 2 here, it's going to be 6. 6 minus this is 5. If I put negative 1 is 3, 3 minus 1 is 2. If I put 0, it's going to give me negative 1. If I put half, okay, if I put half, what are we going to have? It's like negative 3 times half, then minus 1, which is the same as negative 3 over 2 minus 1. 1 here is same as 2 over 2, so it's going to be negative 5 over 2. So you'll have negative 5 over 2. The last one, if I put half, I'll just put two numbers and 1. If I put half, 1 over 2 minus 3, it is the same as I say 2 over 2. 2 over 2 is 1. 1 times this, 3 is 3. Meaning, I have got 6, negative 5 over 2. So it will start negative 5 over 2. Then, if I put 1 minus that is going to be negative 2. Not so. 1 minus that, negative 2. So if I plot this now, we are saying, let me just redo it here. We are saying that negative 2 comma 5, negative 2 is here, comma 5, 5 is there. Okay. Then negative 3 comma 6, negative 3 comma 6 is negative 3 here. If I put negative 3, then comma what? 6, of which 6 it can be somewhere here. Let me put 6 here. So negative 3 comma 6, it will be there. Initially this graph, this line, it will go like that. We don't know where it's ending. Yeah, this is now going to be perfect. You put an arrow. This arrow shows that we don't know where the graph is ending, because we can keep on going, negative 4, negative 5. Next one, negative 2 comma 5. Negative 2 comma 5 again is the same point. Then negative 1 comma 2. Negative 1 is there. 2, it can be here. We can put 2 somewhere here. Then 0 comma negative 1 is here. Oh, in x 0, in y negative 1 is here. Okay. Then half comma negative 5. Half comma negative 5 is here. Again here I need to put a line. Now this is perfect graph. Yeah. It comes like that. Then another one will be half, which is again the same point. Then 1 comma negative 2. 1 is there, negative 2 is here. So this one will also go in this direction. We go there, it goes like that. So you put again an arrow, showing that we don't know where the graph is ending. Yeah, so this is now perfect. So this graph which I've given you now is the perfect graph for that function. Now, you can clearly see that the part A and part C, they are the same. Follow the same principle, solve part C. Part B and D, they are the same. Follow the same principle, do part D and send me the solutions. So let's talk about rational functions. So a rational function, it is in the form of f of x is equal to a over bx plus c. As you can see here, on the denominator we have x. So this is a rational function. So the question is saying, sketch the graph of each of the following function, state their domain and range, and clearly identify all intercept and asymptotes. So let's start with part A. So part A is f of x, which is equal to 7 divided by 5x plus 10. How do we find the domain of the rational function? So to find the domain of the rational function, get the denominator, set it not equal to 0. So I'll say 5x plus 10 is not equal to 0. Why are we setting it not equal to 0? Because we can never have a function a over 0. This is going to be undefined. So the denominator should not be equal to 0. Then solve for x. Okay, so in this case I'm going to say 5x is not equal to, I'll shift 10 to the other side, is going to be negative 10. I'll divide both sides by 5. 5x should not be equal to negative 2. Meaning that my domain in that case is going to be all the values from negative infinity to negative 2, but this negative 2 is not included, union from negative 2 all the way to positive infinity, not included. Or I can put this in set builder notation. I can say the domain will be x is such that x is not equal to negative 2. At the same time, x is a member of all real numbers. Okay, now when you find the domain, in this case we have said x is not equal to negative 2. So the domain is the vertical asymptote. In that case, vertical asymptote is going to be negative 2. So if you find the domain, the same domain which you have here, that is your vertical asymptote. Meaning my vertical asymptote is going to be what? It's going to be negative 2. But for now, let's first talk about, let's first find the domain and the range. So we are saying that the domain for this function is from negative infinity to negative 2, but not included union negative 2 to positive infinity. So then how do we find the range? If you want, you can find the inverse of this function, but here I'm going to use another principle. To find the range in this case, we're going to see if the function is bottom heavy, then the range y is not equal to what? Is not equal to 0. Okay, meaning that my range in that case is going to be from negative infinity to 0, union 0 to positive infinity. Or I can say y is such that y is not equal to 0 if the function is bottom heavy. If the degree of x on the denominator is higher than the degree of x on the numerator, then y is not equal to 0. At the same time, that 0 is going to be our horizontal asymptote. Okay, now that we have found this, let's now go ahead and, so now for part A, I want to start with domain, range, then also I have to identify the intercept and the asymptote. Now how do we find the asymptote? So to find the vertical asymptote, get the denominator, set it equal to 0, solve for x. So in that case, it's going to be 5x plus 10 is equal to 0. 5x will be equal to negative 10. I divide by 5, I divide by 5, x will be equal to negative 2. Like I said, x was not equal to negative 2. This was our domain. The domain is the same as the vertical asymptote. Okay? So now that is my vertical asymptote. To find the horizontal asymptote, if the function is bottom heavy, if the degree of x on the denominator is higher than the degree of x on the numerator, the horizontal asymptote is always 0. Okay? So in that case, the horizontal asymptote is going to be 0. Now how do we find the intercept? To find the x-intercept, set y to be equal to 0. So I'm going to say 0 is going to be equal to 7. I have to find the value of x plus 10. If I cross multiply, I'm going to find that 0 times everything down here is going to give me 0. So it's going to be 7 is equal to 0. We can clearly see that there is no x here. So this equation, this rational function has got no x-intercept. So we don't have x-intercept. Let's see if we have y-intercept. To find the y-intercept, set x to be equal to 0. So it's going to be y is equal to 7. Where there's x, I'm going to put, I'm talking about here, where there's x, I'm going to put is going to be like this, meaning my y will be equal to 7 over 10. So when x is 0, y will be 7 over 10. This is the one which is going to help us even to sketch. Now if this is my graph here, our vertical asymptote is at what? Is at -2. I'm going to put -2 here. So I have to put a dotted line. Then horizontal asymptote is at 0. Now we are going to say we have 0, 0,7 point or 0,7 over 7 over 10. So I'm going to put 7 over 10 here. So 0,7 over 10, it is at this point. Okay. Now what we're going to do there is that it's going to start from there. It has to touch this line, then going there, but not touching the asymptote, running away from the asymptote. Now the way we are doing it for rational function, you are going to reflect this to the other side. In this case, I'm going to reflect this graph here. Then that is going to be my graph. I have to indicate the intercept which I have. In this case, I've got 0,7 over 10. I've indicated here this point, and it has to touch that point. Okay. So for part A, this is the graph. So if you want, you can put the numbers here. You can say this is 1, -1, this is 1, this is 2, 1, 2. You even put some numbers there. That is just okay. So that is it for part A. Okay, let's go ahead and do part B. So part B, we have f of x to be equal to 6 minus x divided by x minus 3. Once again, to find the domain, we have to get x minus 3 not equal to 0, x not equal to 3, meaning that my domain will be from -infinity to 3 but not included, union from 3 to +infinity not included. I can say x is such that x is not equal to 3, x is a member of all real numbers. That is my domain. Now after finding the domain, we can also find the vertical asymptote. The same number here, x is not equal to 3. That is my vertical asymptote. I'm going to say my vertical asymptote is at 3. That's all. Now how do we find the range? We said if the function is bottom heavy, y should not be equal to 0. That is the range. If the degree of x is the same on the denominator and on the numerator, you divide the coefficient of the x. So in this case, we have got the coefficient here where this x is -1 divided by 1, meaning that it's going to be y should not be equal to -1. But again, if you want, you can make x as a subject of formula, then you are going to find. Now at the same time, meaning that my range is going to be from -infinity to -1, union -1 to +infinity. Now what we have to remember here is that the same range, we are saying that y should not be equal to -1. That is my vertical asymptote, my horizontal asymptote at -1. As simple as that. Now I have to find the intercept for me to sketch this. So I'm going to say, to find the x-intercept, y has to be equal to 0. So it's going to be 0 is equal to 6 minus x, then I've got x minus 3. Here I divide by 1, so I cross multiply, it's going to be 6 minus x is going to be 6 minus x. 6 minus x is equal to 0, because if I do 0 times everything here is going to give me 0, and then I'm going to have negative x is equal to 6, negative 6. Negative negative will go, x is equal to 6. So what does it mean? When x is 6, y is 0. That is my y-intercept. My x-intercept, sorry. Now to find the x-intercept, to find the y-intercept, x has to be 0. So it's going to be y is equal to, so I'll say y-intercept on top. So y has to be x has to be 0. I'll say x has to be 0. So I have y is equal to 6 minus 0 over x minus 0 minus 3. So I have my y-intercept to be negative 2. So it's going to be, when x is 0, y is going to be negative 2. Now I can have my graph. So here is going to be my graph. So remember, I have got the vertical asymptote at 3. I'll put here, so it's not supposed to touch this line. I have the horizontal asymptote at negative 1. I'll put it there. Next, 6, 0. Where can I find 6, 0? It's going to be somewhere here. Let's say this is 4, this is 1, this is 2, 3, 4, 5, 6. Let's put it at this point. Then negative 0, negative 2 is going to be somewhere here, because this is negative 1, so negative 2, 0 is going to be here. I'll put 2 here. So this is going to come like this. It has to touch that line, then going there. Again, here we have our point. It has to be reflected here, so it will start from here going there. So it has to go there. You put an arrow because we don't know where it is ending. Okay, so in that case it is like this. It's going like that. So that is our graph for part B. Now we go to part C. In case you are having some challenges on how to reflect it, if I have this, if the graph is here, then it has to be reflected this side. If the graph is here, it has to be reflected that side. That is the principle. So as you can see here, we had a graph here, so it has to be reflected this part. If we had this graph, this part here, it would have been reflected there. Yeah. So now let's go to part C. So part C is saying f of x to be equal to 8x plus 8 divided by 4 minus 2x. So to find the domain, like we said, 4 not equal to 0, we solve for x. 2x not equal to negative 4. Okay, I'll divide both sides by negative 2. X will be not equal to what? 2. That is my domain. So my domain is going to be from negative infinity to 2 not included, 2 not included, to positive infinity. At the same time, this is my vertical asymptote. My vertical asymptote is going to be at 2, because I have to get this, set it equal to 0, solve for x. That is my vertical asymptote. To find the range, we know that if the numerator and the denominator are having the same degree of power of x, then we divide the coefficient. In this case, I'm going to say y should not be equal to, I'll divide 8 divided by negative 2, which is going to give me negative 4. So my range is going to be from negative infinity to negative 4 not included, union from negative 4 to positive infinity. At the same time, my horizontal asymptote is at negative 4. So the range is the vertical asymptote, the domain is my the range is my horizontal asymptote, the domain is my vertical asymptote. That's the principle which is there. So now I'm going to get rid of this and say my vertical asymptote My horizontal asymptote is at -4. So I have to find the intercept. So how do we find the intercept? To find the x-intercept, set y to be equal to 0. So it's going to be 0 is equal to 8x plus 6 divided by 4 minus 2x. I divide here by 1, then I cross multiply. Now from here I can see that I'm going to have 8x plus 6 is equal to 0 times everything here is 0. So it's going to be 8x is equal to -6. Then I divide it by 8, I divide it by 8, x will be equal to 2 into 6 is -3, 2 therefore. So when x is -3 over 4, y is 0. That is my x-intercept. I go to y-intercept. How do we find the y-intercept? To find the y-intercept, set x to be equal to 0. So I'm going to say y is equal to 8, where there's x I'll put 0, plus 6. I'll divide this by 4 minus 2, 0. So my y will be equal to 6 over 4, which is the same as 3 over 2. So when x is 0, y has to be 3 over 2. As simple as that. Now let's try to sketch this. So you use sketching, it's very easy. We have just to use the intercept which we have just found. Okay, so if our intercept is not going to be correct, then it's going to be hard for us to find the correct answer. So in this case, we know that our vertical asymptote is at 2. Or let me just do this. Is at 2, so I'll have this. I'll have this at 2. That's where I have my vertical asymptote, so it has to cut there. Okay, then the horizontal asymptote is at -4. At -4, so I'm going to put -4 here. That is my horizontal asymptote. Now we can see that where can we find -3 over 4, 0? That point is supposed to be here. X is negative, so it's going to be somewhere here. It's going to be, because -3 over 4 is approximately 0 point something, so I can say it is just near 0 here at this point. Another one, we have 0,3 over 2. Where can we find 3 over 2? 3 over 2, we can find it here. It's 1 point something, which is just here, meaning that it's supposed to touch this point here. Starting from here, touching these 2 points, then going there, but running away from the asymptote. Now I have to reflect this down here, so this is going to be like this. So that is going to be my graph. Okay, that is going to be my graph, and this is not part of the graph. You can just get rid of this. Yes, so that is going to be our graph. So as long as you know how to find the intercept, then the graph is going to be easy for you. So that is it for C. Now let's go ahead and find and graph D. D is f of x is equal to -2 divided by x squared minus 5x. So to find the domain, we get x squared minus 5x not equal to 0. We solve for x. I can factor out x here. So x will be x minus 5 not equal to 0. X not equal to 0 and x minus 5 not equal to 0. So x not equal to 0, x should be not equal to 5. So the domain is going to be from negative infinity to 0, not included, union from 0 to 5, not included, union from 5 to positive infinity. That is my domain. Okay. Then I also know that my domain, these values which I've just found here, this is my also vertical asymptote. So my finding vertical asymptote, we are just setting this equal to 0, so for x. So it's the same as I have 2 at 0 and at 5. What of the range? To find the range, you can first find the horizontal asymptote. So if the function is bottom heavy, the horizontal asymptote is 0, meaning the range is y should not be equal to 0. Okay, so y should not be equal to 0. We are going to have negative infinity to 0, union 0 to positive infinity. So that is my range. Then now I have my my horizontal asymptote and vertical asymptote. Now I'm remaining with the x and y intercept. To find the x-intercept, y has to be 0. So it's going to be 0 is equal to negative 2x squared minus 5x. If I cross multiply here, I'm going to have negative 2 is equal to 2. X is not existing here, so we don't have x-intercept. You say no x-intercept. Then you go to y. So I'll say y, to find the y-intercept, x has to be 0. So y will be equal to negative 2 x, this is going to be 0 minus what? 0 minus 0, which is going to be undefined. We also don't have what? The y-intercept. So how are we going to sketch our graph? Okay, if we don't have the y-intercept, this is what we are going to do. We're going to have our graph, which is going to be like this. I'm going to use the coordinate. Okay, I'm going to use the coordinate. So if I want again here, okay, I'm going to use the coordinate, and the coordinate which I'm going to use in this case, I'm going to do this. I'll say x, y. Then we are saying that x should not be equal to 0, at the same time x should not be equal to 5. I'm going to plug in the values. In this case, I'm going to put, I have got 0 and 5. I'm going to put 2 numbers up, 2 numbers down. Again here, 2 numbers up, 2 numbers down. So I'm going to start with negative 2. Or if I want, I can just put one number. I'm going to put negative 1. I have to jump 0, then I'm going to put 1. Okay, then again 5, a number on top of 5 is going to give me what? It's going to give me a 4, and then let me put also 6. So in this function, if I put negative 1, what do we expect to have? It's going to be negative 2. We have negative 1 squared. That is going to be negative 1 squared is 1. It's going to be 1 minus 5, or 1 plus 5, which is going to be negative 2 over 6, which is negative 1 over 3. So I have negative 1 over 3. Now if I put 1, let's see, if I put 1, it's going to be negative 1, then I'm going to have 1 minus 5, which is going to be negative 2 over negative 4. This is going to give me what? This is going to give me 1 over 2, which is half. What if I put 4. But before I go anywhere, even here I can see something which is going to be like this. Before I even finish, I can graph using this, just those two to coordinate, because the main important coordinate which I have, the one for positive, this is the only one I'm going to have for positive. So I have this. I'm going to have, I have at 0, I have my vertical asymptote, also at 5. Okay, at 5. So I'm going to say this. Now if I go there and say where, or if I want, I can even plug in 4. Let's see. If I put 4 where there is x here, is going to be 4 squared is going to be 16. So I'm going to have negative 2 over 16 minus, what is 4 times 4 times 5 is 20. I'm going to have negative 2 over 16 minus this one, 16 minus 20 is going to give me negative 4. Again, I'm going to have half. Okay, I'm going to have a positive. So what next? I'm going also to have 6. If I put 6 there, it's going to be 6 squared is 36 minus 6 times that one is 30. I'm going to have negative 2 over 3. Then it's going to go back to negative 1. It's going to be 1 over 3. So now from here I can see that I have negative 1 comma 1 over, let me put 1 here, negative 1 to be here, then that negative 1 over 3, let's put it here. So horizontal asymptote is 0. Let's not, we have to put 0 here. So I'm going to put this point to be negative 1 over 3, meaning at this point, that is where I'm going to have that one. So I have 1 comma 1 over 2. In x I have 1. Let's say our 1 is here. Okay, so we have our 1 in x is here, and our y, half in y, let's say it is somewhere here. So I'm going to have this point. Another one, I have got 4 comma in x 4, which is here. Okay, 4 here. Then again I have got that point. Okay, so if you have got 2 points here, another point which we are going to have is 6. That 6 is somewhere here, and that is going to give us negative, we said negative 1 over 3 is going to be somewhere here. It's going to be here. I can see from here that my graph is going to be like this. I have these 2 points. If I've got these 2 points, this graph is going to come like this. It has to come there, then it goes there. Then I have got also these points. It has to touch that point. This point going there, not touching the asymptote. Again, this point going here. As simple as that. Now I've used this method because I don't have the x-intercept, I also don't have the y-intercept. That's the reason why I've just gotten, if you discover that you don't have x-intercept and y-intercept, what you're going to do is you have to get the vertical asymptote. In this case we've got 0, so you have to get two numbers from the right, two numbers from the left, or you can just get one number, it's okay. One number from the left, one number from the right. At the same time, you have got 5. You have to get it one number from the right, which is going to be 6, and one number from the left, which is going to be 4. Now plug in here and then sketch it. It's going to come out perfect. So that is D. Now let's see how we can sketch E. So E, I have f of x to be equal to x plus 3, then x squared plus 4x minus 5. But before we solve E, in a case where we have f of x is equal to x squared minus x plus 1, how do we tend to find the vertical asymptote? So if the numerator is has got the highest degree of power, we don't have the horizontal asymptote. We said that if the denominator is having the highest degree of power, we say the horizontal asymptote is 0. If the numerator and the denominator, they are having the same degree of power of x, you get the coefficient, you divide them. So in a case where the numerator has got the highest power of x, you don't expect to have what? Horizontal asymptote, meaning we don't have horizontal asymptote. Okay, so now let's go to E. E is saying, we know that to find the domain, we have to get this, set it not equal to 0. We know that the product in this case is -5, the sum is 4, the factors, what will be our factors? In this case, my factors will be +5 and -1, because +5 times -1 is going to give me -5. +5 minus 1 is going to give me 4, which is true. So I'll have x plus 5, x minus 1 not equal to 0. So x should not be equal to -5 and x should not be equal to 1. If the coefficient is 1 here, I just get the factors which I have to be my answers. So my domain will be from -infinity all the way to -5, union from -5 all the way to 1, union from 1 to +infinity. At the same time, my vertical asymptote is at -5 and 1. Now let's find the range. To find the range, in this case, this function is bottom heavy. The degree of power of x on the denominator is greater than the degree of power of x on the numerator. So y is not equal to 0. So the range will be from -infinity to 0, union 0 to +infinity. Now this is also our horizontal asymptote at 0. Now I can have my x-intercept. To find the x-intercept, y has to be 0. So 0 is going to be x plus 3 divided by x squared plus 4x minus 5. Next, I'm going to cross multiply. I'm going to have x plus 3 is equal to 0 times everything here is 0. X is equal to -3. So when x is equal to -3, y is 0. That is my first intercept. So that is my x-intercept. Let's find the y-intercept. So when y is equal to 0, when x is equal to 0, so to find the x has to be 0. So it's going to be y is equal to 0 plus 3, where there's x I am putting 0, 0 plus 0, 0 plus 4 times 0 minus 5. I'm going to have 3 over -5. So when x is -3 over 5, my y is 0. That is my x-intercept. Now I'm going to have my graph. I have everything. So I'm going to have, here is my graph. So at -5, I have my asymptote, and at 1, I also have my asymptote. So I have 2 points. -3, 0, I can find this point here. This point here. Because I can say this is z, or let me just do this. this is negative, this is -1, this is -2, -3, -4, meaning this point is here, -3, 0. -3 over 5, 0. I can find this point somewhere here. Yes, this means that if I've got 2 points which are just opposite to each other, this means that this graph is going like this. It has to touch this point, it comes here, it comes like this. Now what you have to do is this part here, this part, you can see that at this point this has to be reflected. We have forgotten to put the horizontal asymptote. This part here, we know that this is our point and this is our point, and this is where this is turning. This has to be reflected that side. So this side I'll also have this. Again, this side is turning at this point, so it has to be reflected this side. So I also have another, I'll reflect it this side. So that is my graph for E. So let's now go to part F, where we have f of x to be equal to 2 divided by x squared minus x minus 12. So to find the domain, we get the denominator not equal to 0, we solve for x. So this is a quadratic, the product is -12, the sum is -1, so the factors will be what? Let's see, what will be the factors here? I think the factors which we can have is -4 and +3. So this plus this is -1, this time that one is -12. So like I said, the coefficient here is 1, so there is no need of you saying x squared, that is just wasting time. X squared minus 4x plus 3x minus 12 is not equal to 0. This is just the same as just getting this coefficient. So I have x plus 3 not equal to 0. So I can clearly see that x will not be equal to 4 and x will not be equal to -3. So my domain is going to be from -infinity to -3 union -3 to +4 union 4 to +infinity. That will be my domain. Now my vertical asymptote is at -3 and 4. Now let's see how we are going to find the horizontal asymptote. So the horizontal asymptote, the function is bottom half is 0. Okay, then at the same time the range y will be not equal to 0. The horizontal asymptote is the same as the range, so you just say y is not equal to 0. So meaning it's going to be our range to be equal to -infinity to 0 not included, because it's not equal to 0, 0 not included to +infinity. That is my range. Let's go ahead and find the x and y intercept. So to find the x intercept, y has to be 0. So I have 0 is equal to 2 x squared minus x minus 12. I cross multiply, here I have 2 is equal to 0. So x is not existing, therefore we don't have x intercept. So we don't have x intercept, it can't touch x. So let's see if we have y intercept. So y intercept, x has to be 0. So I'll say y will be equal to 2, I have 0 squared minus 0 minus 12, which is going to be just negative 2 over 12, which is y will be equal to negative 1 over 6. So if x is 0, y is negative 1 over 6. That is the only intercept I have. So let's see. So now we don't have x-intercept, and the graph is not supposed to cross x because we don't have x-intercept. We only have y. So I'm going to say, here is my graph. My vertical asymptote is at negative 3 and 4. So let's say this is negative 1, negative 2, 1, 2, 3. Okay. Then we have to put this again here, this. Now we know that horizontal asymptote is at 0. It's not supposed to touch that line. Now we have got 0 comma negative 0 comma negative 0 comma negative 1 over 6. Negative 1 over 6 is approximately 0 point something. So we can just put it somewhere here. Let's say that point is somewhere here. Now I only have one point here. I want you to understand me here. I only have one point. If you have got only one point, meaning that it has to touch just this point, starting from here, it has to come there, then coming here. Now we know that this, we can see a curve. The curve is somewhere here. So there we need to refract. So I'm going to have the refraction here. Even here I've got a curve. This part here, it has to reflect there. So it has to come like this. You put the arrows because we don't know where it is ending. So in that case, for F, that is our graph. Now let's go to G. So we have got our G as f of x to be equal to 5x squared plus 1. Then we have 2x squared minus 32. To find the domain, get the denominator not equal to 0. So 2x squared not equal to 32. We divide it by 2 by 2x squared is not equal to 16. I get the square root both sides. This is going to be plus or minus now. X will be not equal to plus or minus 4. So x is not equal to 4 and x is not equal to negative 4. My domain is negative infinity to negative 4 union negative 4 to 4 union 4 positive 4 to positive infinity. That is my domain. So my vertical asymptote is at negative 4 and 4. Done. How do we find the horizontal asymptote? If we can clearly see that the numerator and the denominator, they are having the same power of x, so we get the coefficient. So in that case, my horizontal asymptote is going to be at 5 over 2. So range is y is not equal to 5 over 2. So my range will be negative infinity to 5 over 2 not included union 5 over 2 comma what, positive infinity not included. Now let's find the x and the y intercept. So to find the x-intercept, y has to be 0. So it's going to be 0 is equal to 5x squared plus 1 minus 2x squared minus 32. Okay, now here I have 1, so I cross multiply. I'm going to have 5x squared plus 1 is going to be equal to 0. So I shift that other one to the other side, is going to be negative 1. I divide both sides by 5, even here by 5. X squared will be equal to negative 1 over 5. You can't square a number and have a negative outside. It's not possible. So therefore, we don't have x-intercept in this case, because it is x squared. You can't square a number and you need to expect to have a negative. It's not possible. So we don't have x-intercept in that case. So I'm going to say no x-intercept. You have to write that statement, no x-intercept. Then you go to y. Finding y-intercept, x has to be equal to 0. So in this case, it's going to be y is equal to 5 0 squared plus 1. Then I'll have also 2 0 squared minus 32. Okay, so I'll have 1 over negative 32. So my y-intercept is at negative 1 over 32. So when x is 0, y is negative 1 over 32. Let's keep that. So this is going to be similar. So now if I have my graph, I have my vertical asymptote at negative 4 and 4. So I have 4 and negative 4. I'm going to put it here. I have to put a dotted line. Even here, a dotted line. Now, the horizontal asymptote, this is the vertical asymptote. The horizontal asymptote is at negative 5 over 2. Negative 5 over 2 is approximately 2 point something. So 2 point something, let's say this is 1, 2. So 2 point something, I'll just put it here. That is going to be my point where I'll have 5 over 2, which is negative. So I'll put it there. Now, we have got only one intercept. Okay, that is what we have. So let's see, how is our graph going to be like? We don't have x-intercept, so the graph is not going to touch the x-intercept. That is what we should know. So at 0 comma, so you have this point here, negative 1 over 32 is approximately negative 0.032, somewhere there. So which is just near this point here. I can say this point. You just approximate to say this is the point. So you say this point is our negative 1 over 32. So if we only have 1 point, remember, if you have got 1 point and then we have got the horizontal asymptote, okay, we have 2 vertical asymptote. So this is going to cross the horizontal asymptote. So it's going to come like this. It has to touch, it's the same as the one we were solving. It's going to come like this. It comes there, then it comes here. But remember, it's not supposed to touch. The reason why it's going in this direction, because we can't put it in that direction, because we don't have x-intercept. It can't touch x in that case. Okay, remember, this curve here has to be reflected here. So I'm going to reflect this one to come this side. Okay, it's going to come here, so it will come there. Again, that part has to be reflected here. Now, in this case, if I have our vertical, we said our vertical asymptote was what? It was or our horizontal asymptote, I mean. Our horizontal asymptote was we divided the coefficient, which was 5 over 2. Okay, yes. So that is how our graph is going to be like. So it has been reflected that other side, again that other one has been reflected there. Okay, now let's do the last part. The last part, we have f of x to be x squared plus 5x plus 4, x squared plus 2x minus 6. Minus 16 is 15, not 16. So I'm going to say my x, to find the domain, we have to get this not equal to 0. So here is a quadratic product negative 15, sum positive 2, factors we have positive 5 and negative 3. So that positive 5 minus 3 is going to give me that one. It's going to give me positive 2. Then times I'm going to get negative 15. So I have x plus 5, x minus 3 not equal to 0. So I'm going to say x should not be equal to negative 5 and x should not be equal to 3. Next, that is going to be my domain, meaning that my domain is from negative infinity to negative 5 union negative 5 to 3 union 3 to positive infinity. At the same time, my vertical asymptote is at negative 5 and 3. Let's go ahead and find the range and the horizontal asymptote. If the numerator and the denominator, they are having the same degree of power, then we divide the what? We divide the coefficient. So in that case, it's going to be 1 divided by 1 is going to be 1. I'm getting this. The coefficient here is 1, the coefficient here is 1. So the range y should not be equal to 1. So the range will be from negative infinity to 1, not included, 1 to positive infinity. As simple as that. Now let's go ahead and find the x-intercept. So the x-intercept, y has to be equal to 0. So in this case, if y is 0, I'll have x squared minus 5x plus 4. Then I'll divide it by x squared plus 2x minus 5, 15. If I cross multiply, I'll have x squared minus 5x plus 4 is equal to, this time 0 is going to give me 0. So I'll have my product, which is 4, positive 4, sum negative 5, factors, I believe the factors is going to be negative 4 and negative 1, because negative 4 minus 1 is negative 5, negative 4 times negative 1 is positive 4. So x minus 4, x minus 1 not equal to, this has to be equal to 0 because we are finding the x-intercept. So x will be equal to 4 and x will be equal to 1. So when x is 1, y is 0. At the same time, when x is 4, y is also 0. So I have these points. So now let's go ahead and find the y-intercept. So these are x-intercepts. So you say x-intercept is that x is equal to 1 and x is equal to 2, or x is equal to 4. So to find the y-intercept, x has to be 0. So here is going to be y is equal to 0 squared minus 5, 0 plus 4. 0 squared plus 2, 0 minus 15. So 0, 0, 0 are going to have 4 over negative 15. So y-intercept is that when x is 0, y is negative 4 over 15. Then I can have my graph. I can have my graph here, which is going to be like this. My vertical asymptote is at negative 5. I'll put negative 5 here and at 3. What of the horizontal asymptote is at 1. I'll put 1 here. After putting 1, now we have our coordinate. We can put them there. We have got 1, 0. 1, 0 is here. This point, I'll say it is 1, now, 0. It is at this point. What of 4? We also have 4, 0. 4, 0, I'm going to find it here. This is 3, meaning 4, 0 is this point. Another point, I have 0, negative 4 over 15, which is approximately somewhere here. So this is just telling me to say this graph will come like this. It has to start from, let me use different color. It has to start from this point, but it has to touch these 2 points. Let me do it again. Starting from there, touching these 2 guys, it has to come here and come there. Okay, that is going to be our graph. Or if you want, I want this graph to be neat, it can start from here. So long it touches these 2 lines, then it goes there. Yes, like this. Now we also have a point. This is another point which you have. It has to touch there. This is another point. But remember, this part here, this part which you have, it has been reflected here. The opposite of it has to be reflected there. So you have to reflect that one again here. So that is going to be our graph in this case. So that is it for sketching the rational functions.